Okay guys, moving on now to 7.2. Our topic here is simplifying trigonometric expressions. Now we start by revisiting all of the identities that we looked at last time, because we'll be utilizing those again, and even some more than we didn't touch on last time. And so again, this is just kind of a review of what the identities are. So we'll need those again today for this section and really for the entire unit. All right. Now, before we move on, though, and look at the problems, here's something that I want to make sure that we discuss and understand. You have some of these identities that have sine squared of u. All right, so let's talk about that for just a moment. What does that mean? Okay, here's the thing that I want you to make sure that you understand. Okay, sine squared of x. Okay, what that's equal to is sine of x times the sine of x. Okay, and what it is not equal to is the sine of x squared. Okay, so sine squared of the angle is not equal to sine of the angle squared. So we need to make sure that we are aware of that before we start using the identities with sine squared in it. Okay, so these two are not the same. Taking sine of an angle times the sine of the angle is not the same as taking sine of the angle squared. Okay, and we can illustrate that right now by looking at this. Let's see if we can find the value of the sine of pi over 2 squared. All right, see if we can find the value of pi, sine of pi over 2 squared, which would be equivalent to this. Okay. How can we do it? Let's just go right into Desmos and see if we can get a value. So I want sine, am I still in radians? Yep. Let's say we want sine of, need another set of parentheses, pi over 2. We'll close that off, and I want that to be squared. Oh. Okay, so notice the value of this is 0.62. Okay, now notice that that is not going to be the same as the sine squared of pi over 2. Remember, which is equal to the sine of pi over 2 times the sine of pi over 2. Okay? Notice that these two now are going to be different values. So if I go sine of pi over 2 times the sine of pi over 2. Okay. All right. I don't get the same value. That's equal to 1. All right. So notice they are not the same value. So they are not equal to each other. And if you wanted to put that straight into the calculator, you could go sine, and we want to come back out here and do sine squared. Put the squared there of pi over 2. Then notice we get the same answer of 1. All right. So when you're putting into Desmos, that's what you've got to do. You've got to kind of click back out and put the squared there, and then put the angle inside of it. Okay. But the main thing to notice is that these two are not the same. They are different. Okay. So keep that in mind. All right. Now let's move through and see what types of problems we're going to be looking at. All right. So this is a matching exercise. Match the trigonometric expressions with one of the following. So you're trying to match equivalent expressions. You're trying to see which one of these this would be equal to. Which one of these this would be equal to. And we're going to use our identities to figure that out. And so let's go ahead and start by seeing, okay, what can we change these into? That's a good start. And then you will see how things develop from there. So what can we change cotangent into? Well, we can change cotangent into either 1 over tangent or cosine over sine. Now, before, and let me just say this from the beginning, this is kind of like putting a puzzle together. All right? So you want to see which one is going to allow you to get to what you're trying to get to your destination. Now, here's the problem. I need to pick which one of these is going to be the best way to go, or I'm wasting my time, right? So if I look at the other function that's there, secant, secant is 1 over cosine. Well, if I change cotangent to this, right, then I can make the cosines cancel and simplify it. Okay, if I change it to this, there's nothing that can be simplified there. All right, so that's kind of what we are going to be looking to do. And notice all of these choices here don't have a fraction in them. So that can kind of give you a clue as to which way we want to go. So what do we want to change cotangent to? We want to change it to cosine over sine. And secant can be changed to 1 over cosine. All right. Now, once again, how does that help me? Because the cosines are going to do what here? Cancel out. I'm left with 1 over the sine of x. And we can also change that. 1 over the, what was it? 1 over sine. 1 over sine is equal to cosecant. So I'm going to change this to cosecant of x. And that now matches one of my responses. The answer is A here. Okay? All right, so there you go. Let me see here. What else do we want to try? What about one like this? All right, so with cosine squared and secant squared, so now we're getting into some of the Pythagorean identities here. And so with cosine squared, I could change that to 1 minus sine squared if I wanted to. And cosecant squared minus 1, cosecant squared minus 1 can change to tangent. All right. Now, here's the deal. I'm not going to change cosine squared because that's going to change it from a one-term expression to a two-term expression. If you're trying to simplify, you don't want to go from one term to two terms. You want to take it down as many terms as you can. So we're going to leave cosine the way it is for now. Now, sometimes you might be working these and then go down a road and it doesn't work out, and you might have to back up and start over. That's a possibility, and you will have some of that. But now we can change secant squared minus 1. Secant squared, bring this over here and change that to a minus 1, this equation here. And then secant squared minus 1 is equal to tangent squared. So now I'm going to replace this with tangent squared. All right, so from here, let's see what we can do. All right, let's see. From here now, cosine we're going to leave as it is for now. And cosine squared, we really don't have anything that we could change that to anyway, right? Let's see. And we could change it to cosine times cosine, but we're not going to, and you're going to see how that's going to work out here in a minute. So we're going to leave that as cosine squared. But tangent, I am going to change to tangent x times the tangent of x. All right? And so as this moves forward now, you're going to see where this is progressing. So cosine squared is going to stay the way it is. Now, what can tangent be changed to? Well, tangent can be changed to sine over cosine. And that's going to help us out since we've got two of them with making this cancel. So now you can kind of see why we left this the way it was. So now tangent is going to change to sine of x over cosine of x times sine of x over cosine of x. All right. So now what does that become? Cosine squared of x times sine x times sine x is sine squared of x over cosine squared of x, when I multiply those together, now we kind of see where the payoff is. By leaving this as cosine squared, I've now gotten to a point where I can make those two cancel out, and then that's going to leave me with sine squared of x, which is one of my answers. So that is C. Okay? Now, like I said, intuitively, you may not have known at first to leave that as cosine squared, but even if you changed it to cosine x times cosine x, once you get to here and solve this, say, hey, I've got cosine x times cosine x down here in the denominator. I got cosine x times cosine x here in the numerator. I can take that back to squared and just make them both cancel out. Does that make sense? Or even if you elected to go cosine x times cosine x, times sine x over, all that is one fraction, over cosine x, you could cancel out the cosine x twice. That would be another way that you could get there. But like I say, there are going to be some problems with, simplifying these expressions with the identities and verifying the identities, that you may go down the road a little bit and decide, hey man, this isn't working out, I've got to back up and replace it with something else and try again. That is going to happen. All right, so just be prepared for the possibility of having to do that. What else we got here? So secant to the fourth power, we can call that secant squared times secant squared, all right, minus tangent to the fourth power, we're also going to call tangent squared times tangent squared. Okay? And so anytime you've got something higher than squared, it's always the right step to take it down to squared or below, because why? You don't have any identities that involve anything higher than squared. So there's nothing you could do with secant to the fourth power. There's nothing you can do with tangent to the fourth power. So you always want to try to get them down to squared or first power. Otherwise, you can't even use any of your identities. All right. So from here, what can we do? All right. Let's think about this for a minute. Okay, secant squared, secant squared. Okay, so secant squared is equal to 1 plus tangent squared. All right. So if I could write that out twice, and if I come back here now and let's see what tangent squared is equal to. Tangent squared is equal to secant squared minus 1. All right, so if I wrote those in terms of tangent and wrote these in terms of secant, that's not going to help me. But one thing that is going to help me is if I can get them all in terms of one thing. So if I either get all these in terms of tangent or all these in terms of secant, that's always a good thing, because then you can start combining stuff together and simplify. Have a good weekend. All right, so now if I were to take this, right, and let's change these to tangent so I can have all these in terms of tangent, right? So remember, secant squared is equal to 1 plus tangent squared. So this now is going to be 1 plus tangent squared x times 1 plus tangent squared x, right, minus, and we're going to take this back to tangent to the fourth power of x, and then you will see why that helps here in just a moment. And the reason why we're taking this back to the fourth power is because, look at this. When I multiply this out, what's tangent squared times tangent squared? Tangent to the fourth. So let's go ahead and distribute that out. So 1 times 1, that would be 1. And then 1 times tangent squared is plus tangent squared x. And then tangent times 1 would be plus tangent squared x. But then tangent squared times tangent squared is tangent to the fourth. All right. And then at the end of this, we've got minus tangent to the fourth x. Okay? Now, how does that help us? That helps us because this now is gone, right? 1 plus tangent squared, okay, 1 plus tangent squared I can now take to secant squared, back to secant squared. And remember, if I'm expanding this out to get something to cancel, once we're done with that, if we can change it from 2 terms back to 1, we're going to do that. So 1 plus tangent squared, again, is equal to secant squared x. All right. This is gone, plus tangent squared x. And lo and behold, if we look back up at the choices for matching, this is one of them. That is choice F. All right. So like I say, it's kind of like putting a puzzle together sometimes. You've got to just kind of think about what can you do to transform this into something else that we've got up here to choose from. Okay? And, if you've gotten stuck, you might want to look up here and say, okay, I've got this, that I haven't used yet or whatever, and then it's in terms of secant and tangent squared. Hey, I've got secant and tangent squared here. I can make it fit. What about the last one, though? The last one we'll be using one of our other identities. So first thing I'll do is I'll split the squared up. So that would be cosine of pi over 2 minus x times cosine of pi over 2 minus x. All right, so I'm splitting that up. Okay, so we've got that. All of this now is still going to be over cosine of x. All right, so we're in good shape there. All right, so now we can take a look at one of our cofunction identities here and change this part. Cosine of pi over 2 minus x. Cosine of pi over 2 minus x is equal to sine of x. So I'm going to change this into sine of x times the sine of x over the cosine of x. Okay, so one more step and we'll have what we need. I can take sine of x over cosine of x. Sine of x over cosine of x is tangent. And so sine of x times the tangent of x, that is choice D. All right, so there you go. And so, like I say, the way to get better at these is to just become more familiar with all of the identities. The more you use them, the more familiar with them you will get. Like I say, if you start changing something and go down a road that doesn't work or come up with a match, you may have to backtrack and kind of start over and try a different route. And, some of these will have more than one way to arrive at this. Like some of these may have had more than one way to get from here to here or to get from here to here. Okay, that's possible too. It's kind of like when you were solving proofs in geometry. Sometimes some proofs have more than one way to get it. It's kind of the same thing with these types of problems. And you'll see that as we move on, especially when we get into verifying identities, which in essence is just proving something to be true. Okay, so that's it for now, and we'll continue on next time.